So today we're going to be going through a new section. It's going to be section 3, and we're going to introduce functions. So today what we're going to examine are and determine if a relation is a function. We're going to determine if a graph represents a function, and then we're going to find the domain and range of a function. Now, one of the concepts that we used in a previous math class is that function. Now, there are going to be different ways that we can define a function, and we're going to begin by defining a function as a special kind of relation. And so by this definition, a relation is which each x-coordinate is matched with one y-coordinate is said to be described y as a function of x. Now, I know that sounds kind of weird, but the idea is it's saying that if I have an x-coordinate, and as it maps to some sort of y-coordinate, what it's implying here is that this x-coordinate can only be mapped to one y. If that x is mapped to a different form of y, it's not going to be a function. Okay, it's just going to be a relation still. So there's going to be different ways that we can examine this. There's going to be a numerical way of examining this, a graphical way, and an analytical way. We're going to focus on the analytical way tomorrow. But now, if we're going to look at numerically, we just simply need to examine this and say each input, or x, must be matched with only one y value. So in this first example here, if you noticed, my -1, it's mapped to two different values. -1 is mapped to both 5 and 0. So because my -1 is mapped to more than one value, I'm going to say that this is not a function. So look at another one. Now this is just a bunch of points, right? This is a different representation. And so in this set of points here, if I want to determine if this was a function, notice 2 is mapped to 5 and 2 is mapped to 7. So because 2 is mapped to two different values, 5 and 7, this is also not a function. Now let's kind of take this idea and translate it over to graphs. Now I could look at this, right? This is just a set of points again, and I could examine and say, well, is this a function or not? Well, this here is an issue because 1 is mapped to 3 and 1 is mapped to 4. So since 1 is mapped to 2 or more values, it's not a function. And then this one down here, -2, 1, 2, 3, okay, you don't have an x value being mapped to more than 1. So this set here is a function, and this set here is not a function, but let's transition this over to what it could look like in a graph. Now notice here, this 1, just like what we said here, because of this issue, this can't be a function. This 1 is mapped to this y value and this y value. Well, if I were to pick one, which one is it going to be? And that discrepancy is the reason why we can't classify it as a function. Now, this graph here, -2, there's no discrepancies. 1 isn't mapped to two different values, 2 isn't mapped to two different values, 3 isn't mapped to two different values. And so because there's this, there isn't that discrepancy, each x is only mapped to one y, that's visually why we can say that this is going to be a function. Now, there's a special theorem, or there's a special way that we can look at this. It's called the vertical line test, and it says that a set of points in the plane represents y as a function of x if and only if no two points lie on that same vertical line. And if we look back at this example here, if I were to draw that vertical line here, it crosses here and it crosses here. And so it fails that vertical line test. Whereas this one over here, no matter where I draw that vertical line, it's going to pass. And so that's why I can say through the vertical line test, this is not a function and this is a function. Now, another thing just to kind of point out, you're not drawing one vertical line. You have to imagine these vertical lines, there's being like an infinite number of these vertical lines being drawn, and if at any moment one of those vertical lines fails, it is not a function. Because we can't just get cute and say, oh, well, if I draw my vertical line here, then it's not going to be a function, yay, or it is going to be a function, yay. Well, because it fails here, that's why I can't say that it's going to be a function. So imagine you drawing an infinite number of those vertical lines, and then if you find one area in which it fails, therefore it can't be a function. So let's practice a few more. It says use the vertical line test to determine which of the following relations describes y as a function of x. And so here it fails, and so therefore it's not a function. But on this other one, no matter where I draw this vertical line, it's going to pass, and so therefore I can state that this graph is a function. For these two examples here, right here, this is where the issue is going to happen. If I draw that vertical line test, it's going to fail because it's going to pass through those 2 points, and so therefore it's not a function. But in contrast to this example, if we look at that value there, it's going to cross the graph here, but it's not going to cross here. There's no point there. It's a hole, and so it's not going to cross, and so that's why it's going to pass it, because it's only hitting 1 point, which is this one. And so therefore I can say that one is a function. Now we're examining domain and range. Now it says suppose the relation f describes y as a function of x. The sets of all the x and y in coordinates are given special names. Now the domain is going to be the set of all the x coordinates of the points in f. And then the range is going to be the set of all the y coordinates of the points in f. So to look at this in terms of just like a few set of points, the domain are all the x values. So -3, 0, 4, and 5. And then the range are going to be all the y values, which in this case is just going to be 1 and 2. Now I don't need to repeat myself, right? Because we established that with sets, you don't repeat yourself, you just write it once. But now what happens when we get a little bit more abstract? Because if I were to ask you the domain and range of this graph here, this is where things get kind of like, okay, like what's going on? Now, the reason why this example seemed easier versus this example is this one was very concrete. I have exact points here, and from those exact points, you establish what the domain is. From those exact points, you establish what the range is. But for here, well, I have an x value here and 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 here, and it just keeps going on. I have x values everywhere there. So because I have all these, it's almost like it's abstract because technically there's an infinite possibilities. And so because of these infinite possibilities, we're going to have to use interval notation or even a set builder notation to help define what my domain and range is. I think interval notation is easier. Now to do this, what we're going to do is we're going to kind of project the image of the graph onto that number line. So imagine you're just smushing, because we know that domain deals with the x values. So imagine that you're taking this graph and you're like smushing it up against the line. Now if you were to flatten it up against the line, it's going to look something like this. You're going to have this open circle here, and then all of this graph up here is going to get flat here, and then this is going down forever, so all that's going to get pushed up and flattened onto that number line. And so once you project it onto that number line, it's really easy to look at that and determine what my domain is going to be. And so since this goes on forever, I can say that my domain is going to be from -infinity all the way to 1. And since that's an open circle, it's going to be a non-included value. Now let's do the same thing and let's look at the range. So since the range is the y values, we kind of have to take this and we have to flatten it onto that y-axis. Now if I take this and I flatten onto the y-axis, you may be thinking, oh, this open circle needs to go here. But because it's filled in on this side, it's going to fill in that open circle. So we don't have to worry about that. And so by smushing this graph onto that line, I'm going to get this number line. And so I basically took this number line and I rotated it. So imagine rotating that number line. So this is -infinity all the way up to 4, -infinity all the way up to 4. And I just did that because then it's a little bit easier for us to imagine. And so now being able to write what my range is going to be, that's going to be from -infinity all the way to 4. So let's practice here. Let's find the domain and range of these two. So if I wanted to find the domain is just going to be all the x values given here. And so all the x values given is going to be -4, -3. Now I know there's 2 here, but I don't need to worry about that, right? We don't do repeats. -2, +1, 0, and +1, or -1 and +1. And then my range Okay, now we look at the y value, so we have 1 here at -1. So -1, and then 0. We have at 1. We have it at 2. We have 1 at 3 and 4. And so that's going to be my domain and range in that graph. Now on this graph here, we know that this is going to be a little bit more abstract, and so we need to project the image. So if I flatten this, flatten this, flatten this, flatten this, I'm going to get a number line that looks like this. And it's going to stop there, and if I flatten that onto there, we get a number line that looks like this. So then my domain, it's going to be from -infinity all the way to -1. Now there's more, so union, and then from 1 all the way to positive infinity. So my domain is going to be from -infinity all the way to -1, union, and then from 1 all the way to positive infinity. Now let's examine my range. Now with my range here, I'm going to project everything this way. Everything's going to get projected onto my y number line. Now if I do that, everything's going to get flat on here. There's no gaps, there's no spaces, and so my range is going to be from -infinity to positive infinity. In closing today's lesson, what did we learn today? Well, we talked about what a function is and how a relation is a function. And we also took a look at the domain and range and how to find the domain and what the domain is, and how to find the range and what the range is of a function. Now, if there's anything else that you felt that you've learned, please do share. And then a couple of questions that I would like you to respond to, and that's what is a function? So what was a definition that we may have used, or in your own words, what do you think a function represents? And then how do I find the domain from a graph? So even though I went through a process in how to find the domain from a graph, what did that look like to you? So maybe even put that in your own words. Now this does conclude our lesson. If you have any other questions, please leave them in the comments.